PyTorch is an open source machine learning library for Python. It is used for applications such as natural language processing and computer vision, and it was originally developed by Meta AI. PyTorch redesigns and implements Torch in Python while sharing the same core C libraries for the backend code. PyTorch developers tuned this backend code to run Python efficiently. They also kept the GPU-based hardware acceleration and the extensibility features that made Lua-based Torch. PyTorch provides several modules such as AutoGrad, etc. It contains many other useful submodules such as data loading utilities and distributed training functions. So now, let's move to the agenda. First, we will jump to the introduction of PyTorch. After understanding what PyTorch is, we will see the installation, Tensor Basics and the backpropagation. Hello everyone and welcome to Intellipaat. Before we move ahead with the video, please make sure that you subscribe to our YouTube channel and hit the bell icon for regular updates.
So let me explain you what is exactly PyTorch. PyTorch is an open source machine learning library which is used for applications such as computer vision and natural language processing. PyTorch was originally developed by Meta AI. Along with that, PyTorch redesigns and implements Torch in Python while sharing the same core C libraries for the backend code. Now, let's see the features of PyTorch. PyTorch is a simple, intuitive and stable API. Also, it has very high performance on GPU with CUDA. Along with that, you can use PyTorch for backpropagation, and it is extensively used for the neural networks building blocks. So these are the features of PyTorch. So after understanding what is PyTorch, now let's see its installation. So now moving to the installation part, we will be using here Google Colab. Let me open the Google Colab and show you how you can install PyTorch. So I will go simply on the web browser, that is nothing but a Google Chrome, and I will just write here Google Colab. And I will click on this, and then I will just click on the first one, that is Welcome to Collaborate. So this is a link where I will click, and I will just go and click on the option New Notebook. Let me rename this. I'll just write here simply PyTorch _ tutorial. Now, we will see the installation of how to install PyTorch. So I'll simply write here import torch. So this is the way to install PyTorch. So here you can see that the command has been executed. So we have successfully installed PyTorch. So after installing PyTorch, we will see the Tensor Basics. The reason behind that, PyTorch defines a class that is basically called Tensor, which is used to store and operate on homogeneous multidimensional rectangular arrays of numbers. It is similar to the NumPy arrays but can also be operated on CUDA capable NVIDIA GPU. So now we will perform some basic operations on PyTorch in Google Colab. So as I already told you that PyTorch will give you a tensor class, right? So now let's see different functions that we can use using PyTorch. The first function that I will be using is nothing but a rand function. So here I have already imported PyTorch, that is nothing but a torch library. So if I'm writing here torch.rand, and here if I'm writing here 2,2, so while executing it, you can see that I am getting a two-dimensional tensor, right? So here you can see that we are having 2 rows and 2 columns. Alright. Now the next function that I will be using here is empty function. Empty function returns a tensor that is filled with uninitialized data. So if I'm writing here, let's suppose torch.empty, and let me put here x, and inside this empty function, let's suppose if I'm giving any value, random value, if I'm writing here 4, and if I'm executing it, and let me print this, so I'll just simply write here print function, and inside this print function I'll just write here x, and on execution you can see that I am getting a value or data that is uninitialized, and here I have given 4, right? So we are getting a 4 values here. Now moving next, if I'm writing here torch.empty, and here if I'm writing here 2, 3, let me again assign it with the x variable, and once again I'll just print here print x. So here you can see that on execution we'll get the output as two-dimensional tensor, which contains 2 rows, that is 1 and 2, along with the 3 columns. And here if you see the values or data, this is uninitialized, right? So that's what the empty function gave you. So now we have already seen the one-dimensional tensor along with the two-dimensional tensor. Now, so if you want to create the three-dimensional tensor, so now let's see with the help of empty function how you can create. So I'll simply write here torch.empty, and here I will just write here 2, 2, 3, and on execution you can see that these are nothing but the 2. The first 2 I got here, and then 2 rows, right, and 3 columns. So this is nothing but a 3D tensor, right? So let me comment it down. I'll just simply write here 3D tensor. Alright, and this is nothing but a 2D tensor. Let me comment it down also. This is nothing but a 1D tensor. So after creating 1D tensor, 2D tensor, 3D tensor, let's say if you want to create a 4D tensor with the help of the empty function. So how can you create it? So once again I'll just simply write here torch.empty, and let me assign the values here. So if I'm writing here 3, let's say 2, 2, and let me give any random value, let's say here 4. So you can see that here we are getting basically 4D tensor. So this is 1, this is 2, this is a 3, and then we are nothing but 2, 2, 4, right? So we are having here 2, right? And then we are having 2 rows. Here you can see that, and then 4 columns, 1, 2, 3, 4. So this is a representation of 4D tensor. Similarly, you can create 5D tensor, 6D tensor, and so on. So this is a way you can create a empty tensor, right? So after understanding how we can create a tensor using empty function, now we'll see what are zeros function and ones function. So if I'm writing here, let's suppose torch dot zeros, and inside this function, if I'm writing here, let's say 2, 2, and if I'm executing it, so on execution you can see that we are getting the 2D tensor. So basically I have used here zeros function, so it will give the 0 value. So here you can see that I am getting the 2D tensor which is having 2 rows and 2 columns, and the values that are filled inside is nothing but a 0. Let's say if you want to create a tensor which is having only one value, right? When I say one value, that means inside that tensor we are having only 1 as a value. So let's suppose if I'm writing here torch dot ones, and if I'm writing here the value 2, 2, so you will see that I will get only 1, and there will be 2 columns and 2 rows. So this is the way you can create zeros and ones, right? So guys, always remember that PyTorch will give you a tensor, right? So let's see some other functions also. So the next function that we are having is the size function. For that, let me put inside this into the x. That is nothing my assignment operator. And now if I want to print it, I'll just simply write here print x, right? Now if I want to know the size of this tensor, so I'll just simply write here x.size function. So here you can see that the size we are getting is nothing but 2, 2. That shows that it is having 2 rows and 2 columns, right? So moving next, if I want to see the dimension of this tensor, so what can I do? So this is my x, right? So if I'll write here simply x.nDimension, and if I'll execute it, so it will directly tell that we are having 2-dimensional tensor, right? Now let me show you one more scenario. If once again I am creating a variable x in which I am creating a tensor, let me write here torch dot ones, and this time I'll just take 3, and this time I will take here 3 rows and 3 columns, but I will specify here the data type. So to specify data type, let's suppose I want the data type as an integer. So I'll just simply write here torch dot int, and let me here print it. So you can see that on execution I am getting an integer, but earlier if I didn't specify the data type, you can see that I was getting a float values, right? So this is a way in which you can specify the data type. moving ahead, let's say if you want to create a tensor using list, we can create it. So now let's see using PyTorch how we can create a tensor using list. So I'll just simply write here torch.tensor, and inside this tensor function I'll create a list, and inside this list let me write here 4.2, 3.1, and let me add some more values. Let's say if I'm writing here 5, 2, and let me execute this. So on execution you can see that we have created a tensor using list, right? So now going forward we will see some arithmetic operations. So let me create here random variable that is nothing but x. I'll just simply write here torch.rand. Since I want to create a random tensor, so I'll be using here the rand function. So inside this rand function, let me give here the shape as 2, 2. So it will give nothing but a two-dimensional tensor. I'll also write here y is equal to torch.rand, and I'll just write here 2, 2. And let me print it. You can see that while execution or while seeing the output will get different values, because we are using here the rand function. So now I've already executed this, and now if I'm executing at different time, that is next time, you can see that I will getting different values. Another time you can see the another values. Now if I want to fix this value, so for that what I will do, I just want that whatever the value I'm getting, it's fixed. So for that I will be using the manual seed. So if I'm writing here torch.manual_seed, and inside this function let me write a random value. So let me write here 42. Now if I'm executing it, so on execution you can see that this is my tensor, right? Now once again if I'm executing it, you can see that the value will not change. Now let me perform the arithmetic operations here. So if you want to perform the arithmetic operation, let me just simply write here z. This is a new variable, and I will just write here x plus y. And if I am printing here print z, on execution you can see that, so this will give you the addition of this one and this one. Again, this is nothing but a second row and second column. So in this way it will add up and it will give me the output. So now after seeing addition, we are having here some functions that we can use using PyTorch. So let me show you. Instead of writing x plus y, what I can do here, I'll just simply write here torch dot add, and inside this add function I'll give the parameter x and y. And if now I'm executing it, you can see that I'm getting the same output. Similarly, you can do it for the subtraction. The first way is nothing. You can just simply write here z or z is equal to x minus y, and just write here print function, and inside that z. Now the another way is to, I'll just use here PyTorch, and I'll just simply write here torch.sub and x comma y. Now on execution you can see that again I'm getting the same output. Similarly for multiplication and divide. So for multiplication I'll be writing here torch.multiplication, and that is nothing but a mul function, and inside that I'll just simply write here x comma y. Similarly for division also. So this is a way where we can perform the arithmetic operations like addition, subtraction, multiplication and division. Alright guys. Now let me show you one more thing. Now what I will do here, I will once again create a tensor using rand function. So let me write here x. So here I'll just write here x torch. So I'll write here x is equal to torch dot rand, and then again 2, 2. The same I will just copy it, and I will simply put here in y. And I will just write here print x, print y. So this is a basic operation, right, using rand function, which we have already seen. Now if I'm writing here y dot add underscore, so when I'm writing here underscore, that means we are performing in place operation. So when I'm telling it's in place operation, that means we are doing something called manipulation, right? It may be in the form of addition, it may be in the form of subtraction, multiplication or division. So inside this, if I'm writing here x, so you can see that, so what I'm doing here exactly, inside y, I'm just adding it with it to the x. Now, if I'm performing here, z is equal to x plus y, and if I'm writing here print z, so you can see that I'm getting here the addition, but the output is different. So what's the difference between this and this? So here you can see that I'm performing here y dot add underscore x. So what will happen here? This is our y, right? So it will add this one with the x one. So if you'll add 0.86 plus 0.94, we'll get 1.81, right? Similarly, it goes for the 0.56 plus 0.13, and the addition we'll get here 0.7009. Similarly for these two also. So guys, always remember that whenever I'm writing here underscore function, it is basically an in place operation. Okay? Nothing but a add underscore. You can also perform here multiplication underscore or subtraction underscore, right? So these are nothing but an in place operation. So after understanding it, now let's see if we want to fetch any particular record in PyTorch. So what we can do for this? So let me create here nothing but a torch dot. Once again, I will use here rand function, and inside this rand function, I'll just simply write here, let me write here 5,3. So you will see that I will getting a 2D tensor, right? So which will give me 5 rows and 3 columns, right? Now if I want to fetch the first column record, so this is nothing but my first column, right? This is the first column, this is second column, and this is my third column. So for that, I'll just simply write, let me first store into a variable x here, and let me print it. So if I'm writing here x, and I'll just inside this list, basically a list is denoted by a square bracket, and if I'm writing here comma, and then I'm just writing here 0, so you can see that I'll get here the first record. That is nothing, first column record, right? Now if you want to fetch the second record, that means a second column, right? So I'll just simply write here 1. So you can see that whatever the data or value we are here in the second column, right, we'll get it. Similarly for the third column, I'll just simply write here 2. So this is the way where you can fetch the records of any specific column, right? Okay guys, so after understanding it, let's move to the another part. That is nothing, we're gonna use the item function. Now if you see that if I'm writing here x dot item, so if I'm executing it, you can see that I'll get an error. Why? Because item function will give you only one element tensor. So how we can use here item function? So before using item function, let me create another PyTorch tensor. So I'll just simply write here torch dot rand, and inside that I will just give here one value. So let me print it. So on execution, you can see that we'll be getting a 1D tensor, right? So this is having only one value. Now here I will use here x dot item function. So if I'm writing here x dot item, so on execution, you can see that we are getting the exact value. So this item function will give you the actual value of one tensor, right? And make sure that always remember that it is only used when there is only one tensor. Okay guys, now if you want to see the shape of a tensor, so which function shall we use? So once again I will create a tensor. So for that I will be using a PyTorch. So I'll just simply write here torch dot. Once again I will be using a rand function, and let me give the shape here as 4,4. And if I'm printing here print x, so you can see that I will getting a 4 columns along with 4 records. That is nothing but rows, right? If you can see that here we are having a 4 cross 4 shape, right? And it is nothing but a 2D tensor, right? Now if I want to change it into a 1D tensor, so we'll be using here view function. So if I'm writing here x dot view, and you can see that 4 cross 4, that is nothing but we are having 16 values. Now 16 values I want to just put into a 1D tensor. So simply I will just write here 16. So you can see that earlier we are having the 16 values, but it was a 2D tensor. Now in just 1D tensor we are getting the 16 values, right? Now this is the 16 values we are having. Then we can also put into a 3D tensor. So how to put it? I'll just simply write here x dot view. So can we write here 2, 2, 4, right? Because 2, 2 will be 4 and 4 into 4 will be 16. 2, 2, 4. And now if I am clicking on this, you can see that on execution I'm getting the same values but in the form of 3D tensor, right? So this is a way you can shape a size of a tensor. So from a 2D tensor, we have saved the size from to 1D tensor and similarly to a 3D tensor, right? So let's move ahead. So now guys, let's say if we are having a tensor and we want to convert into a numpy. So how we can do it? So just let me write here in the comment, converting tensor into a numpy array, right? So how can we do it? Let's see. So for this, let me create a tensor which will be having only 1 as a value. Okay, so I'll just write here torch dot ones and I'll just write here 5. Let's suppose, or you can take 6 also. Any value you can take it. So here you can see that I'm having a 1D tensor, that too with 6 values, and each value is having 1, right? So I'll just assign it to the a variable, or let's say x, or any variable you can take, right? Now after that, what I will do, let me print it. Again the same output will get. Now let me check the type of this a variable. As we already know that the type is nothing but a tensor, right? So on executing it, you can see that I will getting a as a tensor, right? Let me write here type. Okay guys, so you can see that this is a class having torch.tensor. Now I want to convert into a numpy. Okay, so I'll just simply write here, let me create a variable b. I'll just write here a.numpy. So this is a way in which you can convert a tensor into a numpy array. Now let me print it. So if I'm writing here print b, you can see that from tensor it has been converted to numpy. Now you might have a question that how we will get to know this is a numpy, right? This is a numpy array. So for that, once again I will be using a type function. So I will simply write here print function and I'll write here print type, and inside this type function I'll just simply write here b. So on execution you can see that the tensor, that is 1D tensor, we have converted into a numpy array. Alright guys, now let me write here print, and inside that let me print here underscore underscore so that you will not confuse. Now it looks good, right? So this is a way in which you can convert a tensor into a numpy array. Okay, let me remove one u from here. Okay guys, also guys, I want to show you one thing. I have already talked about the in place operation. So if I'm writing here a dot add underscore, and let's suppose inside this I am taking the value as 3, right? So you can see that a was over here tensor, right? Then 3 will be added to 1 and it will be a 4, right? Now what happens if I'll print here b? What will happen actually? So if I'm writing here print function inside that b, so guys you can see that here I'm using the in place operation. So in a I'm adding the value as 3. So here you see that our a was nothing but a tensor, right? So the new tensor will be having the value as 4. Now if I want to print b, if I'm writing here print b, so on execution you can see that I am getting the 4 for the b also, even though I have manipulated a only. The reason beside this is nothing but tensor and numpy will be pointing to the same memory location in CPU. So if you are doing something in place operation on a, it will definitely reflect on the b also, right? Similarly it goes for the multiplication, subtraction and division in place operation too, right? So this is the basic idea. So let me explain you once again. So this is our basic tensor in which we have converted a tensor into numpy array, and if we are performing here in place operation nothing but add underscore 3, so you can see that it will be added 3 in all of the values and the value will be 4, but I didn't perform any operation on b. But once I am printing b, you can see the value I am getting here 4, right? So whatever will be the operation done on a, it will be reflecting to the b also, because the reason is simple, tensor and numpy will be pointing to the same memory location in CPU. Okay guys, now we have already seen how to convert tensor into a numpy array. Now it's time to see how we can convert numpy to a tensor. So for that, I'll just simply write once again in the comment down numpy or before that let me write here convert numpy array to a tensor, right? So let me create here numpy. So to create a numpy, first I have to upload a library or module that is nothing but a call as import numpy, and I'll give here alias as np. Okay, and let me create a variable a, and here I'll just write here np dot ones, and inside the ones function I'll just write 5, and if I'm printing here print a, so you can see that on execution we'll getting a numpy array which will be a 1D. Okay, if you are having a doubt, just go and then type print and type function inside that. You can check it out as a numpy. Okay guys, now let me convert into a PyTorch. So how to convert it? I'll just write here b variable, inside that I'll assign here torch dot from underscore numpy, and here I'll just write simply a, and let me print it. So print, inside this print function I'll just write here b, and here you can see that from numpy how we have converted the numpy to a tensor. Now that's it guys. Now if you want to perform the operation, let's say if I'm writing here, let me write here a plus is equal to 2 if I'm writing, and if I'm writing here print a, so this is my a, right? You can see that I'm getting a 3. Now let's see if we are doing some operations on a, how it is reflecting to the b. So if I'm writing here print b, you can see that the output will be getting the same as 333, right? Because I already told you the reason, tensor and numpy will be pointing to the same memory location in CPU. So this is the basic idea about how we can convert a tensor to numpy and a numpy to a tensor. So after understanding how to convert a tensor to numpy and a numpy to a tensor, we'll see how we can do backpropagation using PyTorch. Okay guys, so let me write here in a comment backpropagation in PyTorch. So why do we use backpropagation? So let me give you an idea about backpropagation. So we use backpropagation to compute derivatives. Okay, so let me give an example so that you can understand it. So for that, let me just create a tensor. So I'll just create a tensor here, x equal to torch dot tensor, and let me write here the float value. Let's suppose if you're not writing float value, right? And if you are printing x, because I have used here a tensor function here this time. So on execution, you can see that we are getting the output here, right? Now, why I was telling that, let me write just integer value. Now if I'm writing here once again, requires underscore grad is equal to true. So why I'm writing here requires underscore grad? Because I told you that backpropagation is used to compute derivative. And when I'm talking about gradient, what does it mean? It means the derivative part, right? So by default, in this torch.tensor, this is a tensor function in which if you are not writing requires underscore grad is equal to true, by default it's false here. So that's the reason we usually write here requires underscore grad is equal to true. Now let me execute this. So on execution, you can see that we'll get an error. Why? Because I am having here integer value. So if you see here, it's showing runtime error. Only tensors of floating point and complex data type can require gradients. So if I'm writing here, let's suppose 4, and if I'm writing a dot, now on execution you can see that I will not be getting an error. So always remember, whatever the input we are giving, it must be a floating point, right? It should not be integer. So this is my integer in which I have already given the requires underscore grad, because I want to check the backpropagation. I want to see how the backpropagation is done in a PyTorch. Now let me show you an equation. So let's say if I'm writing here y is equal to x cube. So this is a way we can represent in a Python. And if I'm writing here print y, now what is our x here? X is 4. So 4 to the power cube. 4 into 4 is 16, and 16 into 4, what is it? 64, right? So on execution you can see that it will give us as 64, right? So this is our equation. So now what will be the derivative of this equation if you see here? So derivative of this will be nothing but, let me comment it down, it will be dy upon dx, and it will be 3x square, right? This is nothing but it's coming from the chain rule. If you are doing the derivative of x cube, it will be a 3x square. So let me write here 3x and let me write here square, right? Why I'm commenting it down, I will tell you later, cause we gonna perform here back propagation. So if I'm writing here y dot backward function, so why I'm writing here backward function? When I'm writing y dot backward, so what will happen? My equation will convert from y equal to x cube to the dy upon dx, that is nothing but is equal to 3x square. So it will give me the derivative part. So whenever you, as soon as you are executing the backward function, you will get the derivative of the equation. Now how to check it whether I'm correct or not? So now if I'm printing it, print x dot grad. Why I'm writing here x dot grad? Because I want to see it. So let's say the derivative of x cube will be 3x square, and what's our x value? It is 4. So 4 square will be 16, and 16 into 3. So 16 into 2 will be 32, and 32 into 3, if we execute here, it's showing an error because we don't have to write here parenthesis. Let me execute now. So 16 into 3 will be nothing but a 48, right? So you can see that as soon as I am using this backward function, this y equal to x cube will be changed into a derivative 3x square, and x value is 4. So 4 square is 16, and 16 into 3 is 48, right? So this is a basic example. What happens if I am taking a list here? So let me create a list for the back propagation this time. So I'm creating a list as L1, and in this list let me take 2, 3, 5, and let me take some more values 6, 9, 11, and I'll take here 13, 17, 18, just random values, right? Now let me create the tensor here. So I'll just simply write here x dot torch dot tensor. Since I want to calculate the gradient, right, that is nothing but a derivative part. So I'll just simply pass here L1, and I have to write the parameter that is requires underscore grad, right, which will be equal to true. And on execution, let me just show you how it looks like. If I'm executing it, I am getting an error because I told you that it shouldn't be integer. So let me make it floating point values. Now I'm executing it. You can see this how my tensor looks like, right? So what I will do here, so let me create an equation, this time a little bit complex. So if I'm writing here, let's suppose y is equal to x to the power 4 plus x to the power cube, let's say. So what will be the dy upon dx? Let me first print y here. So instead of x, what will happen? These values will go, right? So in the first place, the value will go 2, right, to the power 4, and this will be the values here, right? Okay guys, so these are the values, but it is in the form of exponential form. So let me just change it to a simpler version. So if I'm writing here x to the power cube and x square, and now you can see that the value is looking like this, right? So now I will be using a backward function. So backward function will do what? So it will give us the derivative, that is dy upon dx, and it will be equal to 3x square. So it will be simply 3x square, and plus it will be x to the power square is nothing but 2x, right? So let me write it. Okay, let me comment it down. So I want to calculate the gradient, and gradient is nothing but a derivative, right? So now what I will do here, I'll just simply write here y dot backward. But as soon as I'm executing it, you can see that I will get an error. The reason behind this is gradient will be taking here scalar outputs. So for the scalar outputs, what I will do here, I will just simply sum it, or you can also take the mean. So let me write here y dot sum. So what I will do, this is a y function. If I'm taking sum of it, you can see that it will add up all the values. Let me store into the z. Now, since you can see that once our z value is coming, let me print it. It's nothing but a scalar, right? And here we are having a lot of values. So this is our z. Now if I'm writing a z dot backward, so now z dot backward So as soon as I'm executing here z dot backward, what happens? The dy by dx will be nothing but 3x square plus 2x. I'll get the derivative. So now you might have a question that once we are executing it, it should be a scalar input. In this case, we are taking the sum. Let's say if we don't want to take the scalar input, so in that case, what we will do? So in that case, you have to create the vector, right? So coming to this case again, now we have already taken z dot backward. Now if I want to check my gradient, I'll just simply write here print x dot grad. And if I'm executing it, you can see that I'm getting the value. So here you can see that the equation x 3x square. So x value is here nothing, but the x value is here 2, right? So 2 square is 4, 3 into 4 will be 12, right? 12 plus, and again the 2 value, 12 plus 4, 2 into 2 will be 4, 16. So here you can see that I'm getting 16. So as I told you that backward function will give you the derivative, and the x dot grade, as soon as you are executing it, you will see the value, the x value will be coming from here, and it will go inside this function that is nothing but in our derivative, and it will print it. So in this way, you can do the back propagation using PyTorch. So this is a basic idea about the PyTorch, how you can use the PyTorch just like same as NumPy, how you can do the back propagation in PyTorch, right? So that being said, I wish you good luck on your PyTorch journey. I hope these steps will help you plan your learning schedule. That's all we have for this video. I hope this video was informative for all of you guys out there willing to take your career to new heights with PyTorch. Thank you for being here till the end of this video. If you have liked this video, make sure to hit that thumbs up button. Also, don't forget to enable subscribe button to never miss any update from Intellipaat YouTube channel. Thank you all.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.